Hey everyone, welcome to Code Harmony. Today we'll solve LeetCode from ID 36 valid Sudoku. This problem is pretty standard and asked in a lot of companies. You can also see it has been asked in almost all the tier 1 organization. And you have already solved this problem, or this problem is pretty easy for you. You can further take the next step to solve Sudoku solver challenge. This LeetCode problem ID 37. In this problem, we'll be given a Sudoku. We just have to validate that. And in case you are not aware of this, what Sudoku mean, you'll get the understanding once we move ahead in the problem statement. And this problem will be based on hash table and matrix. Let's get started. Determine a 9x9 Sudoku board is valid. Sudoku board is always 9x9 size. It's a game, and they just want us whether this given game is valid or not. Only the filled cell need to be validated according to the following rules. What are these rules? These are the rules of Sudoku. Each row must contain digits from 1 to 9. Each column must contain digits from 1 to 9. And each the 9 3x3 sub boxes must contain digits from 1 to 9. And what is the note? A Sudoku board partially filled could be valid, but it is not necessarily solvable. Okay, so they are saying that you don't need to worry about whether it can be solved or not. You just need to validate whatever is given in the problem statement. You just have to do that. Only the filled cell need to be validated according to the mentioned rules. Okay, see, what is a Sudoku? Sudoku is a 9x9 matrix where we have 9 3x3 sub matrices, and every sub matrix is this portion is going to have numbers from 1 to 9. Every single sub matrix is going to have numbers from 1 to 9. And every column, let's say this column, is going to have numbers from 1 to 9. And this row is going to have number from 1 to 9. So every column is going to have numbers from 1 to 9. And how many cells are in that one row? We have 9 cells. We have 9 cells and we have to fill numbers from 1 to 9. It means every row is going to have number only one time. Every number is unique in every single row. Similar to the column. Column numbers can be from 1 to 9 and we are having 9 possibilities. It means every number is coming one time. It shows that if, let's say, this number 9 is present here. If this number 9 is present, it means this number 9 should not be present again within the same column and within the same row. These are two validations. Apart from that, this sub matrix should also not have that number. This sub matrix should also not have that number. So this is something we need to validate. And if these three conditions are true for every single number, then this Sudoku is valid. The Sudoku game state is valid. Okay. So how do we do that? First of all, I hope you have understood so far that Sudoku is a kind of game where we are given 9x9 matrix and there we are having 9 sub matrices of size 3x3. And every item should be unique within that 3x3 block and within that row and that column. So this is something we need to validate. And if we are checking these three conditions for every single item present on any particular IJ location, then we'll be able to validate this game. So how do we do that? First of all, I need to check every single item in this grid. And if this grid is of size, see, grid size is always 9x9. So check for every single item starting from 0 0, and these are the 9 rows and these are 9 columns. So for every row, every column, if the value is present, if the number is present from 1 to 9, then just start validating that Sudoku. So how do we iterate over this grid? First of all, for row is equal to 0, row less than 9, row plus plus. For column equal to 0, column less than 9, column plus plus. we have row and column corresponding to this Sudoku. And now at this position, whatever is the value, let's say the value present is 2. So this 2 should not be present in that particular row, and in that particular column, or in that sum metric. See, if it is not present in the row, we can check that by taking a hash table data structure. How many rows do we have? We have 9 rows. Is this value present in that row? Yes or no? We can store using hash table. And similar to the column, whether this value is present in the column already or not, we can store that. If it is not present in the row, if it is not present in the column, then we will check for the sum metric. And how do we get the sum metric? That is the only trickiest part for this problem. Copy and paste. So this is my Sudoku. First of all, I will check for every row going from 0 to 9. 9 exclusive, 0 inclusive. For column, 0 to 9. 9 exclusive, 0 exclusive. So this is 9 cross 9 operation I am making, and then I am checking every single value, whatever the value is at row and column. Whatever way the problem is given to us in the form of input. So just use that. If it is character, do that. Like I have not seen that. What is this type of value? So I'm just here to explain you the concept. So for every row column, we have that value. We just need to see if it is already present or not. Already present in the row and already present in the column. It means row and column. This combination, 9 value present in this row and in this column, it should be unique. Now I need to store somewhere that row 1 is having 1. I have already seen. In column 3 with 1, I have already seen. So this is something I need to store somewhere. So I can take them as a key that in row 1 I have already seen 1. In row 3 I have already seen 1. Correct? So just take it as an entry, and if I take it as a string, I can capture it in a set data structure. I'm not putting more focus on how do we store that 1 is already seen in that row or in that column. That is pretty simple. Just use hash table data structure. Just use set that 1 is already present in 1 number of row and 1 is already present in 3 number column. Okay, so that is something I can check by storing all the values in a set. So how do we get to know that it is present in this metric? See, if it is present in this matrix, I need to know what metric it belongs to. For that, let's try to mark the indices completely. 0, 1, 2, 3, 4, 5, 6, 7, 8. 0, 1, 2, 3, 4, 5, 6, 7, 8. This is 0. This is 3. This is 6. This is 0. This is 3. This is 6. If I take any item, let's say ij. If I take ij and then if I'm taking I and then divide it with 3, what will I get? For all of these 3 values, I will get 0. For all of these 3 values, I will get 1. For all of these 3 values, I will get 2. If I am taking row number and row number I am dividing with 3, I am getting which particular block row it belongs to. So it is a part of 0th block row, first block row, second block row. Right? Because we have 9 blocks. 1, 2, 3, 4, 5, 6, 7, 8, 9. 0, 1, 2, 0, 1, 2. 3 cross 3. So taking value of I, dividing it with 3, and taking this, let's say this 8 I am taking as reference. This is 4, 3. So 4 divided by 3, I will get 1. And what about column? For column, we can do the same thing. J divided by 3. J divided by 3. For all of these 3 columns, I'm going to get 0. For all of these 3 columns, I'm going to get 1. For all of these 3 columns, I'm going to get 2. So it means, let's say if I have to store 8, 8 is a part of ith row and 8 is a part of jth row. I will check whether in ith row I have already seen 8 or not using hash set. In jth row I have already seen 8 or not. After that, in 1, 1 block, how I'm getting 1, 1? This is the identity of this block. Let's say every block is identified by the left top block address. And how we are getting that address? Just dividing that indices by 3. Dividing those indices by 3. There can be other methods as well, taking modulus and all, but this is pretty simple. This just came to my mind straight away. So how do we do that? If we have to store it in the set, I can store it in the form of string. That row 4, I am taking 4, 3. Row 4 is having 8. This string I am going to store. Column 3 is having 8. And block, see 4, 3. 4 divided by 3 is 1. 3 divided by 3 is also 1. So block 1 underscore 1 is having 8. So block 1 underscore 1 is having 8. If let's say there is only 8 also present here, this 8 is not a part of same row, not a part of same column, but it is a part of same block. And if I am taking for this 8 is present at 5, 5 block. 5 divided by 3, 1. 5 divided by 3, 1. Because integer we need to take. 1, 1. So in 1, 1 block, do we have 8? Yes, we already have 8. So discard it. And whenever we are getting a first invalid entry, we are going to discard it. This Sudoku is not valid. So that's all about this problem. This is how we can do it. And what did I use here? I just used set data structure. Set data structure where I'm taking key as my string. Why I'm not bothered about the time complexities or overheads of the strings? Because the grid is 9 cross 9 size, not so big in number. 9 cross 9 size. Total how many entries do we can have? We can have around the similar number of entries. See, 9, 9, 36, and for 36 every entry can contribute to 3 position. Let's say this 3 is part of this row and this column and this block. 36 into 3. So overall it is a constant time operation in the worst case, and this is how we can solve it. So the trickiest part of this problem was that, say if ij is having some item, then this ij item belongs to ith row, jth column, which is also understood, and I divided by j and j divided by 3, I divided by 3, j divided by 3 block. So that's the only part you need to understand, and this is also going to be helpful when you are solving a subsequent problem follow-up to this, that if it is a valid Sudoku, see, only a valid Sudoku can be solved. If it is already invalid, we can't solve it. So if it is a valid Sudoku, then the interviewer can ask you, why not you just solve it together, solve it, give me the solution. And to solve Sudoku, how do we do it? We have this metric, and in this metric, how we can solve this Sudoku. At this position, how many items I can have? I can only have those items which are not part of this row, not part of this column, and not part of this block. So whatever are the remaining portion, I can use that. So what are the total possibilities? 1 to 9 I can use. Can I use 1? Yes, I can use 1. I is not part of this row, this column. But might be the case that later on we are not able to solve it. So what do we have to do now? We have to backtrack and check out different possibilities. So trying out all the possibilities, means backtracking. Using backtracking we can solve it, but to validate we don't have to do something special. Okay, that was all about the logic, and now I will show you the code that I wrote a couple of years back. So here what I did is I just took a hash set data structure. For every row, for every column, this is the number, and if this number is dot, how do we check it? In the constraints, board is it 1 to 9 or dot. If it is dot, no need to do anything. Otherwise, check whether this number is present in the row, whether this number is already present in the column, whether this number is already present in the block. And how do we get the block? I divided by 3, j divided by 3. The same logic I have used here. And if it is the first invalid case, then the whole Sudoku is invalid. If there is no invalid entry, it is true. If it is true, only after that we can solve it further. So that was all about the Sudoku problem, and I have already attached the code in the description below. If still you have any doubt, do let me know, and thanks for watching guys. Bye bye.